In 1855, in the northwest corner of Massachusetts, a survey crew stood at the base of Hoosac Mountain and looked at 4¾ miles of solid rock between them and the other side. There was no dynamite yet. There was no compressed air drill that worked reliably underground. There was black powder, hand steel, and men willing to walk into a hole in a mountain and not come out for 10 hours at a time. The plan was to drive a tunnel straight through the mountain, wide enough for 2 sets of tracks, so that the railroads of Boston could finally reach the Hudson River and compete with New York for the trade of the Great Lakes. The mountain did not cooperate. Underneath the topsoil was some of the hardest and most unstable rock in New England, seamed with quartz, riddled with water, and prone to collapse the moment it was opened to air. Men working this project would come to call it the Bloody Pit, and they would earn the name one death at a time, for 22 years, until the 2 ends of the tunnel finally met in the dark, almost exactly where the engineers said they would. If you're enjoying this story so far, don't forget to hit the like button and subscribe. Drop a comment telling me where in the world you're watching from. I love hearing from you. The engineers who took on Hoosac Mountain were working from a plan that looked reasonable on paper and turned into one of the most punishing construction projects in American history. The original idea was to bore from both portals, east and west, and meet in the middle. Someone realized that if a vertical shaft could be sunk down through the top of the mountain to the exact center line of the tunnel, crews could also work outward from that midpoint in both directions at once, cutting the total time nearly in half. It sounded elegant. It required digging a shaft over 1,000 feet straight down through rock that fought back at every foot, then hauling men, tools, and debris up and down that shaft in a bucket on a cable for as long as the project lasted. The central shaft became the deadliest single feature of the entire job, a vertical grave that the men who worked it joked about and feared in equal measure. The rock face itself was attacked with hand drills, the same 2-man method used in stone quarries up and down the East Coast. One man held the steel bit against the rock and turned it a quarter turn between blows. The other swung an 8-pound hammer, and later a heavier one, aiming for the head of the drill inches from his partner's fingers, hour after hour, in tunnel air thick with rock dust and smoke from the lamps. A crew might drill a dozen holes across the face of the heading in a full shift. Each hole was packed with black powder, tamped carefully with a copper rod because iron could spark against the rock, and set off the charge early, fitted with a fuse, and lit. Then everyone ran for the nearest turn in the passage and waited for the blast to bring down a few feet of stone that then had to be broken up, loaded into carts by hand, and hauled out to daylight or up the shaft before the next round of holes could even begin. Progress across the whole job, for years at a stretch, was measured in inches a day. Ventilation alone was its own daily crisis. A heading driven 1,000 feet or more into solid rock, with only one narrow opening back to the surface, filled with blasting smoke, drill dust, and the exhaled breath of dozens of working men, far faster than it could clear on its own. Early in the project, crews simply waited for smoke to drift out before going back to the face, which wasted hours after every blast. Later, engineers rigged crude ventilating pipes and eventually mechanical blowers to push fresh air into the workings, one of several points where the difficulty of this particular mountain forced American engineers to solve problems that had not been solved on this scale before. Lighting was almost as difficult. Oil lamps and candles burned poorly in air, already thin on oxygen, and men worked for entire shifts by a weak, flickering light that barely reached the far wall of the heading, judging the soundness of the rock overhead, as much by ear and instinct as by sight. The rock itself refused to behave the way the surveys promised. In places, the tunnel passed through a fault zone nicknamed the flowing ground, where the rock was so fractured and saturated with water that it behaved almost like wet sand under pressure, sliding into any opening cut through it. Timbering this section required building continuous wooden arches to hold back material that wanted to collapse the moment it was exposed, and even then sections gave way, burying tools, carts, and occasionally men. Crews learned to read subtle signs in the rock face before a collapse: a slight seep of water, a faint grinding sound overhead, a shift in the color of the seam, and a foreman who ignored those signs risked the lives of everyone working the heading behind him. Water was a constant enemy in its own right. Pumps ran day and night to keep the workings from flooding, and when they failed, or when a blast opened a new fissure, the lower sections of tunnel filled with water fast enough that crews had to scramble for higher ground inside the mountain itself. Some stretches produced so much groundwater that steam-powered pumping stations had to run continuously just to keep the heading dry enough to work in, and a mechanical breakdown in one of those pumps at the wrong hour could turn a routine shift into an emergency within minutes. It was inside this project that a chemist and businessman named George Mowbray set up a factory near the west portal to manufacture nitroglycerin on site, because the compound was too unstable to transport safely over any distance on the roads of the 1860s. Nitroglycerin blasted rock far more effectively than black powder, and it cut the pace of excavation considerably once crews learned to use it. It was also a substance that could detonate from a hard bump, a fall, or simply a bad batch mixed slightly wrong, and the men who handled it did so with a kind of grim, practiced calm, because there was no other way to do the job and stay employed. Explosions from mishandled charges, both powder and nitroglycerin, killed workers throughout the project, sometimes one man at a time in a misfire at the face, sometimes several at once when a charge went off before the crew had cleared the heading. Mowbray kept careful notes on his mixing process and pushed hard to convince skeptical contractors that the compound, handled correctly, was worth the risk, and by the later years of construction, it had become the standard explosive at Hoosac, even though most other American construction projects still considered it too dangerous to use at all. The worst single disaster came at the central shaft in October of 1867. A fire broke out at the top of the shaft where the hoisting works stood, likely from an overturned lamp near stored naphtha used to fuel the lighting. The fire collapsed the wooden headworks down into the shaft itself, and the burning wreckage fell on top of the men working at the bottom, over 1,000 feet below, while also destroying the pumps that kept the shaft from flooding. 13 men were trapped underground with no way up and no way to signal the surface. Rescue crews could not safely reach the bottom for almost a year, because the shaft first had to be cleared of wreckage and then pumped out from a mountain of water that had risen in the meantime. Recovery work itself was slow and dangerous, carried out a bucket load at a time, with fresh cave-ins and unstable wreckage threatening the very men sent down to bring their co-workers back up. When they finally reached the bottom, they found the remains of the men who had been trapped there, and among them was a foreman who had gone down that morning, as he did every morning, one more engineer of the project who the mountain did not let back out. For months afterward, the central shaft sat idle, while the project's leadership argued over whether it could safely be reopened at all, and the loss of a full working season on top of everything the shaft had already cost pushed the project's finances into another crisis. If you're hooked on this story, make sure to subscribe and turn on notifications so you never miss an upload. Your support means everything and helps me bring you more emotional stories like this one. The people who ran this project on paper were not spared from the danger either, and that is part of what made Hoosac different from a great many 19th century engineering jobs, where the men who designed the work stayed safely at a desk while laborers took all the risk. The chief engineers overseeing the tunnel were frequently below ground themselves, inspecting headings, checking the line of the bore with survey instruments, and walking through sections that were actively being timbered against collapse. Getting the two headings, east and west, along with the shaft crews working outward from the center, to all meet at the correct point, deep inside a mountain, with no satellite positioning and no laser alignment required constant, careful surveying, carried out in person, often in tunnel sections lit only by oil lamps and filled with blasting smoke that had not yet cleared. More than one contractor associated with running the project died from illness contracted underground, or from accidents while inspecting active workings, and the project burned through multiple contracting firms over its 2 decades, some of them driven into bankruptcy by the cost overruns and the sheer difficulty of a mountain that seemed determined to collapse on anyone who tried to move through it. The state of Massachusetts itself eventually took over direct control of the project after private contractors proved unable to finish it, appointing its own engineers to manage the work through its final and most difficult years. A rare instance of a state government stepping in to personally run a construction job of this scale and danger. The workforce came largely from Ireland, along with a significant number of workers from Cornwall, England, men whose families had worked tin and copper mines for generations and brought that hard rock mining knowledge with them across the Atlantic. Later in the project, Chinese laborers were also brought in, part of the same wave of railroad labor migration that was simultaneously building lines across the American West. Wages were modest, the hours were long, and the men lived in boarding camps near the portals that grew into small, rough towns of their own, complete with the taverns and boarding houses that always sprang up around a project this size and this dangerous. Shifts ran around the clock in 3 rotations so that the tunnel was never idle, and a man might work through the night by lamplight with no way to tell from inside the mountain whether it was noon or midnight outside. Turnover was constant, not only from men quitting over the conditions, but from the steady toll of injury and death that thinned every crew over time. Local doctors in the nearby towns of North Adams and Florida, Massachusetts, treated a steady stream of broken bones, crushed hands, and burns from blasting accidents throughout the project's life, and the small cemeteries near both portals still hold graves of men who never saw the tunnel finished. By the time the tunnel was finished in 1875, the total cost had run to roughly $14 million, several times the original estimate, and the death toll during construction is generally put at close to 200 men, though the record-keeping of the era was inconsistent enough that the true number may never be pinned down exactly. Some died in blasting accidents, some died in the flowing ground when a section gave way without warning, some died of falls down the central shaft, of being struck by falling debris, of drowning when pumps failed faster than men could climb to safety. Others succumbed slowly to lung ailments brought on by years of breathing rock dust and blasting smoke in air that never fully cleared between shifts, deaths that never appeared in any official tally of tunnel casualties but were understood by everyone in the surrounding towns to belong to the same mountain. The nickname the Bloody Pit stuck to the project long before it was finished and has followed it ever since, used by local residents and later by historians as shorthand for just how much this single mountain took from the people who tried to pass through it. When the 2 headings finally broke through and met underground, the alignment was accurate to within a couple of inches over nearly 5 miles of rock, a survey achievement that stood as one of the most precise pieces of underground engineering completed anywhere in the world up to that time, done entirely with chains, transits, and plumb lines, rather than any of the electronic instruments a modern surveying crew would consider basic equipment. The tunnel that resulted, at just over 4 3/4 miles, was the longest transportation tunnel in North America for decades afterward, and it remained an active, working rail tunnel long after the men who built it, and the men who died building it, had been forgotten by everyone except their own families and the occasional local historian who went looking for their names in old payroll ledgers and coroner's reports. The railroad that finally ran through the completed tunnel gave the city of Boston the direct route west it had wanted since before construction began, and towns along the line grew on the strength of freight and passenger traffic that the tunnel made possible for the first time. Modern tunneling has left almost nothing in common with what happened at Hoosac Mountain. Tunnel boring machines now grind through rock at a steady, calculated pace with rotating cutter heads that would have seemed like something out of a dream to a man swinging a hammer onto a hand drill in 1860. Ventilation systems, seismic monitoring, laser-guided alignment, and modern explosives handled by remote systems have taken most of the raw physical danger out of boring through a mountain, though tunneling remains one of the more hazardous trades in construction even today. What has not changed is the basic problem those Hoosac engineers were the first in America to solve at real scale, which is how to keep a straight, accurate line through solid rock when you cannot see more than a few feet ahead of you in any direction, and how to keep men alive long enough to finish the job when the ground itself seems determined to stop them. Engineering schools still study the surveying methods used to align the Hoosac headings, and the project is regularly cited in the history of American civil engineering as the moment the country proved it could take on underground work of a scale previously attempted only in Europe. The Hoosac Tunnel is still there, still carrying freight trains through the mountain today, more than a century and a half after the first survey crew stood at its base and tried to guess what the rock would do to them. Trains pass through in about 10 minutes now, in electric light and open air compared to what the original crews worked in, over a route that cost roughly 1 life for every 1.5 feet of tunnel driven through that mountain. Most of the people who ride freight past that stretch of Massachusetts have no idea what sits above the rail line, or what it took to put the rail line where it is. The mountain is quiet now. It was not quiet for the men who spent 22 years convincing it to let them through. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.